Good morning, everybody. My name is Dominic Case.
My name is Carter Louise.
And we're from Carbon Nation at New Fairfield High School, here to introduce the anemoii fermentation turbine.
So I'm sure that we are all familiar with the devastation that Connecticut has recently received with the past tornadoes. These are images from our own town. A lot of people lost their homes, their vehicles, and some even lost their lives. And there's a direct correlation between this type of devastation, these natural devastations, and the release of CO2 into the atmosphere, which changes the climate, making these sort of disasters far more possible. And us here at C6 Nation are looking to try and mitigate this problem from its source. The U.S. sector of fermentation food and beverage is a massive culprit of release of CO2 gas. They release hundreds of millions of thousands of cubic tons of CO2 gas every single year. The U.S. kombucha industry actually totaled $556 million in 2017 and is expected to grow another 30%, which is a lot of CO2 if you think about it.
One of the largest contributors of carbon dioxide emissions is derived from the crafting of these ethanolic beverages. A study released in 2014 revealed that our industry in question emits 320,000 tons of carbon dioxide equivalent a year. To put that into perspective, that completely fills over 86,000 Olympic-sized swimming pools. One of the largest companies in this sector, AB InBev, releases enough carbon dioxide a year equivalent to that of 66,000 cars. Now, yes, these numbers are quite staggering, but when you realize that this carbon stays in the atmosphere for thousands of years at a time, it becomes truly catastrophic.
The C6 Nation team wants to take a closer look at this issue and do our best to mitigate it. So here we are introducing the anemoii, which is going to take a closer look at the release of CO2 from different fermentation food and beverage industries and find a way to repurpose that wasted emission to actually generate electricity. Our development process was definitely a long one. We are all familiar with how turbines work, but trying to derive the electricity from CO2 was definitely more difficult. We had to contact lots of different experts from all different crafts, so whether that be engineering or the brewing industry itself, we had to take a look at what do the different processes look like and what would be the most effective way to design our tubing and our different fans to get the best electrical output possible. So for our prototype designs, we really focused a lot on our tubes, and we actually ended up utilizing the Venturi principle, which basically says that if you narrow a tube, the fluid or gas in this case that's traveling through it will have more pressure. That was definitely something that we had to play with a lot to find the best size for the openings of the different holes, and also what type of fan would be the best. We ended up using a recycled computer fan, and we didn't even have to reverse engineer it. We found a way to make it work so it would output energy instead of collecting it.
So we tried experimenting with biomimicry, specifically with the fan blades. We wanted to use quaking aspen leaves, which has a design that captures more wind. However, sadly, this didn't have the desired effect. Slowly, over the course of development, we began to implement things like tubing and funnels to utilize, like my partner said, the Venturi principle so that we can get the most efficiency for our product. Our solution to this major concern starts with the excess carbon dioxide produced from fermentation. In the beginning, this carbon dioxide is trapped inside the fermentation vessel. Instead of just venting out this otherwise wasted gas, our product attaches a tube to the release valve where it guides it to the funnel and becomes pressurized. After this, it is sent to a junction box that houses upcycled computer fans where it'll smack into the fans and cause them to spin and thus generate electricity. Corporations are then free to use this electricity and power their facilities without expending additional resources.
So to design the anemoii, we had to contact a lot of different people to get a lot of different inputs on what would be the best way to go about it. We contacted AB InBev, which is actually the largest international brewing corporation in the world. They gave us a lot of valuable insight on how the brewing process works and also how yeast behaves as it is a living organism. There are a lot of different ways, and it has specific requirements for it to live the best. We contacted experts at Crystal Rock, as we did run into a couple problems when we were running our experiments while using one of their jugs. And then we also used experts from BHB who gave us more insight into the fermentation process. So for our anemoii and its pricing, it's going to be priced at $20 with a 50% profit markup. It's important to keep in mind that when we ran these experiments, we did it on a 5-gallon scale, but different brewing corporations that they have at InBev are actually done on 100,000-gallon scales. So we were able to generate around 3 kilowatt hours of energy annually with our 5-gallon experiment. But imagine this on a large industrial scale, you'll be producing far more electricity than what we did on our experiment. So proof of concept is important to keep in mind here.
And please keep in mind that this can certainly be improved. We can swap our parts for specialized pieces and overall improve the efficiency for the product.
So we are C6 Nation, this is the anemoii. We are hoping to help move our world to a more sustainable energy source, and this is one of the best steps forward. We hope that you guys enjoy. Thank you.
Just a few comments. So first, I love the science. So I love how you methodically went through all of that. Love the science back and forth. And I liked even the business model on top of it. With that, I'm not sure that it was 158% margin. It was more like probably 38% margin or something like that when I looked at the facts. But I love how you approached it and went through it, the science supporting it. Made it a business model and took something that's very practical today and an issue today and tried to address it. So good job.
Thank you.
Thank you.
After the CO2 goes through the fan, what happens?
So otherwise, we're not actually changing the way the facilities deal with their CO2, because some can choose to recapture it and use it to carbonate their beverages. Others can just let it vent out into the facility. Our product is allowing them to generate electricity off of the venting CO2. So our plan is not to directly affect the amount of CO2 that the facility produces, but rather allow the facility to not draw as much power from the power supplier.
I just love this idea.
Thank you.
Thank you.
I really do. You guys are you're onto something really neat.
I would just say, if you can, go to that next step. Gosh, just think about what you can do there with that carbon. Because carbon is building blocks of so many things. You can, it probably would be, I don't want to say easy, because nothing is ever easy as you think it's going to be, but would just totally complete that cycle. Super cool.
Thank you.
When you talk to the folks at InBev, were they interested? I'd be interested to think what those experts were wondering.
They were actually very interested. So our instructor was the one who reached out to them, and he shared that they were very enthusiastic about the idea, and they were very thrilled about the prospect of having something to generate electricity from otherwise something that's completely wasted.
Okay, nice job. New meeting,